Hello everyone, we are going to start chapter 15 of your physics class 12th and NIOS class 12th physics. So basically, those students who cannot understand Hindi properly and my all lectures which all in Hindi medium language, although these all are in English medium, but to understand, to speak, to explain everything in Hindi medium. That's why I made a special video for those students who understand only English. So these all notes of my previous lecture. So I will use this type of notes which is already written, and in the short time I will complete all the concepts. So this is the chapter 15, electric charges and electric field. So first of all, we will study about electric charges. There are two types of electric charges. How many types? There are two types of electric charges, positive and negative. And you know what? These are the property of these positive and negative charges. Let me suppose we have the like charges and we have the unlike charges. So between the like charges, the repulsion will be created, and between the opposite charges, the attraction force will be work. That means what? Very simple. Male and female will attract each other, and male and female will never attract each other. So that's the simple concept in this physics also. And next we will talk about conduction. Actually, what is the conduction? Conduction is very simple way. Let's suppose we have a charged body, we have a spherical charged body, and the charged object body is positively charged, and we have another object that is uncharged. When we touch this uncharged body to charged body, then all the charges are moving towards uncharged body, and finally after few times we see the uncharged body will also get charged from charged body, and this phenomenon is known as conduction. And we have the another phenomenon, induction. So actually what is the induction? In induction, we never touch the two objects. We always keep the two objects far away, but due to the charged object, this uncharged body will get charged. That means this is the induction. This will be induced. Induce means inspiration. The word inspiration comes from the induced. Let me suppose any student, any boy, anyway, in your neighbors got a score very good, qualifying IAS, UPSC, high level exam, then you will also inspired. You will also get inspired that I have to do also. Your parents will talk about them, that's the person, that's the boy that qualified that particular exam, but why you are naughty? What? So this is the main way where we talk about without touching the object, this body will get charged by induction, and this phenomenon will known as induction. In the induction process, it's very important, we will have to keep earthing with this uncharged object. Why we use the earthing? It's very simple. In earthing, you know what? There are lot of electrons in the earth. Lot of electrons. It's a sea of electrons. That means free electrons that will help to conduct this uncharged body, and after a few times later we see that this is the uncharged body will convert in charged body. So simply these two phenomena are important that I already discussed to you. Next, conservation of charges, like conservation of energy, like conservation of mass. You studied about conservation of energy. What is the conservation of energy? Energy neither be created nor be destroyed. It's only transfer from one form to another form, from electric light energy, from electric energy to light energy, from electric energy to mechanical energy that are moving a fan. It's transfer from electric energy to heat energy like a heater. So energy neither be created nor be destroyed. The very simple way, in an isolated system, our charges will also conserve. But now the question is, sir, what is the isolated system? It's a very simple. Isolated system means it's disconnect outside the all the boundaries or the everything. When we disconnect everything from outside, that is known as isolated system. During corona time, you know the word isolation, that every family at their home will isolate. All the government authorities, policies, guidelines came that time, do not came do not came your house, outside your house. Why? This is what the isolation. So this is also the isolated system. Let's suppose we have a glass and we have the silk, that we know that I will show you a demo of this type of this phenomenon. We have the few small paper cutting, very small particles of the paper cutting, small parts. We have the few. We have also few that the last class I discussed. So wait a moment, I just create the all the things, like, so I made this all the things. Okay, so we have, I think this is the enough for demonstration, right? Okay, so this is the pen and I will rub this pen with my hair. So I'm just rubbing this pen here and I will connect this pen towards this all the particles of the paper. Look around it, how it's touched and connect. How it's possible? Because of the charge body. Why? Because of the charge body, that we see that an object will get positive charge and another will negative charge. We know that it will attract positive and negative, and that's why you saw that my pen attracts all the small particles of the paper, and that's why the total positive and negative will become zero charge. Now the next word is quantization of charge. Actually, what is the quantization of charge? When we talk about quantized means what? The very smallest particles, very smallest unit, that our body is made from cells, and cells is the single particle that are singly individually exist. For example, to understand properly, we take Indian currency. When we quantize the Indian currency, then the smallest unit that individually exist is 1 rupees. It's also, we can say, 80 paisa, 20 paise, 50 paise, but this time below 1 rupees, it's not current time running in the market. It's only single rupees that are individually exist. That's why we say that the Indian currency is quantized by single rupees. In the same scenario, we say that all the charges are quantized, and the individual particle of the charge will be that will be individually exist is small e, that is the electron, and the charge on the electron is minus 1.6 into 10 ki power minus 19 coulomb. And always remember this charge. Sometimes in the questions it's not given, and it's very challenging when we have not remember this type of these values and we know how to solve the questions, and we said why this is happening with me. So always remember this value is very simple, and n is what? This is an integer format. Like suppose that we have 100 rupees, then we will multiply 1 rupees to 100. Where we suppose we have 549 rupees, that we will multiply 1 rupees by 549. So these all numbers will get like an integer. So that is the only integer that actually we have 10 coulomb. So actually in 10 coulomb, what will be number of such type of this individual smallest unit? How many numbers? These all be collect to make a properly 10 coulomb, and such type of questions also ask in your exam. And what is the Q? Q is the integral multiplication of electric charge. And now it's very important to note here written that all atoms are neutral. Everybody know about it? All atoms are neutral. Why, sir? Why all atoms are neutral? Because in the atom you see that the amount of positive charge and the amount of negative charge always equal. And that case we have suppose 5 positive charge and 5 negative charge, that will make 2 sum ups to give 0, that will neutral. But in the special case when we say that the negative charge is higher than positive charge, and then that time our atom will not in neutral condition. Our atom will, in the case of the negative charge, sometimes we have the negative charge lower than the positive charge. In that case we say that our atom is positively charged. So these are all the cases where we discuss about the previous example, like these types of, these all the atoms are not neutral. because these all the charged bodies. So because we say that uncharged body, this type of atoms are neutral. So basically these all a matter, and matters are constituents to made from particles. Particles are made from molecules. Molecules make from atoms, and atoms are made by three fundamental particles: electron, neutron, and proton. Right? Proton, we have the positive charge, and electron, we have the negative charge. Simple. Right? And the next we have the Coulomb's law. Actually, what is the Coulomb's law? Coulomb's law is very simple to discuss between two charged bodies. Let's suppose we have the two charged bodies Q1, Q2 are separated by a distance of r, and we say that the force acting between the two charged bodies is F. We don't know actually the nature of the charges. If these charged bodies are like charges, then the nature of force will be repulsive force. And when we say that these charges are in the nature of opposite charges, then we can say that the nature of force will be attractive force. So depend on the nature of the charged body, we will say repulsive, attractive, and we are not interested to discuss about repulsive, otherwise attractive force. Only we are going to start Coulomb's law. The first of all, the Coulomb's law between the two charges Q1 and Q2, and distance r between them in a medium. So the first equation from Coulomb's law say that the force between the two charge bodies will be directly proportional to product of their charges, product of their amount of charges. Let's suppose this is the Q1, this is the Q2. So multiply the two charges, and that will be the directly proportional to our force. If we increase the amount of charge to every individual, otherwise both object, then the amount of force will also increase. And if we decrease the amount of charges on the object, then on these objects, single, otherwise both, then our force will also get reduced. So this is the function where one function increases, simultaneously other function will also increase. And when the second function will decrease, the other function will also decrease, and that phenomenon is termed as directly proportional. And look here, it's very simple, a logical reason that when we increase the distance between the two charge object, then we see that the force between the two charge object will decrease. Why? So it's not working properly because the distance are increasing, and the nature of charges doesn't matter, but the value of the charge will get reduced, will decrease. And this is the reason that we say that our force is inversely proportional to this. Our force is inversely proportional to distance, square of distance, not distance. This is the reciprocal of a square of distance. We term as r square, not single r. Many students got confused about here that we use only r as a distance. In the statement, we will have to write the same way, that the reciprocal of square of the distance. From equation 1 and 2, we get a new form, that F is equal to K Q1 Q2 by R square. You know what, in the mathematics, without this equality doesn't mean these all type of equations. These all are useless, no need. So when we will have to make a huge part, then we have to give any proportionality constant. Here the proportionality constant is K, that is the value have 9 into 10 की power 9 Newton meter square per coulomb square. In many times students forget to remember, otherwise don't remember about the unit of this K. It's very simple. Look at this formula. F is equal to K Q1 Q2 by R square. Then after K is equal to F R square by Q1 Q2. And simply F in Newton, R in meter, that means meter square. Q1 Q2 means coulomb square. And simple we get the SI unit of the K, Newton meter square per coulomb square, right? And the next page we have the permittivity of the medium. It's a very important, my dear students, when permittivity of the medium. When we talk about permittivity of the medium, many students got confused in the questions also. Simple. I will try to understand. Listen carefully. Concentrate here. definitely you will understand all the concept related to permittivity of the medium. Look about it. When we talk about air, vacuum, space, this word, why am I using this word? I am just using because of 99% case in your syllabus we will use the medium of vacuum, air. Nothing to say, nothing to mention in the questions. That means we will understand the medium will be vacuum, otherwise air. So no problem. But in the special case, when we talk about the special type of medium, in that case the value of K will be changed. What is the K? This is the K. This is proportionality constant. This is valid. 9 into 10 to the power 9. This is valid for vacuum medium, otherwise air medium. In other medium, the value will change. How? Look here. So actually the concept of K is derived from here. K is equal to 1 upon 4 pi epsilon naught. This is the symbol that is known as, that is we say epsilon naught. Naught means that this is the denotation like O, epsilon, and this is the naught, epsilon naught. And the value of epsilon naught is 8.85 into 10 to the power minus 12 Newton meter square per coulomb square, and this is valid for free space or vacuum. I still remember in my board exam MCQ questions were asked related to the value of epsilon naught, and I got confused that time because 8.85 will show in all the option, but the power of 10 was changed. In few options minus 10, minus 8, minus 9 and minus 12 also. And I still remember I tick out the 10 to the power minus 10 and my answer was wrong. That questions was wrong. So be care. This is the value of 8.85 into 10 to the power minus 12 Newton meter square per coulomb square, and this is the valid for free space in vacuum when we talk about, and this the value came from this value. But when we talk about any other medium, we suppose that in the water, in the glass, in the something, we can say anything. It's not detailing in your syllabus. So I've only discussed a few questions we ask according on the concept of this concept. So this is the specially relative permittivity. What is the relative permittivity? When we compare the permittivity of two mediums, where we will always keep in denominator of permittivity of space, and in numerator we will keep permittivity of medium that are required. So very simple, the permittivity of medium is equal to the multiplication of relative permittivity and simple your permittivity of a space, that give your product will give permittivity of medium, and is also known as dielectric constant K. So sometimes in the questions given the value of dielectric constants, and then you will find this type of this thing. So it's your choice that how you find the value of permittivity of medium by using the formula. And it's a very way to make easy. I tell you a trick to remember, and a very funny way, that when any relatives come to your home, and relatives, so you always buy a special mithai for them. Special mithai. Mithai means what? Sweets. So mithai means what? Medium, special means space, and relative means ER. So this is the trick for remember relative permittivity ER between permittivity of medium and the permittivity of space. And here it's also changed the value of epsilon. That means what? This is the formula that F is equal to K 1 upon 4 pi epsilon Q1 Q2 by R square, and then instead of epsilon we will use this product epsilon naught into epsilon R, that will keep to maintain the value of this formula, right? So in questions it will be more clearly. Okay. So next Coulomb's law is inverse square law, right? Inverse square law between, it's inversely proportional to the distance between the squares, and hold for point charges, not a contact force. This force, especially Coulomb's force, in Coulomb's force we never touch the two objects. We always keep a far distance. Between the distance, the 2-point charge will situate at a proper distance. Something, it may be very few centimeter doesn't matter, and a few meter also, but never ever the touch the body. Okay, and then direction. So when we meet the centers of the two charges, it will give the direction of this force. And then vector forms very simple. You know what, by vector law of addition in the basic physics. If any student Scott felt that physics is very weak for him, he couldn't understand physics properly, and it's very challenges to understand how the concept in any chapter in the physics, then you should watch my basic physics part that I clearly mention all the basics of physics, and that's available in YouTube, and I will give the link in the description of this basic physics. I think you should watch once time. So one time investment, and then after see the magic. All the chapter will be easy for you. You will understand very clearly. Okay, come here. So this is the vector law of addition. You know what? In any vector, this is a format. This is the how to format the vector. How to indicate the vector. So this is the head and this is the tail, and we have the two vectors like vector A and vector B, and we have to sum up the two vectors like vector A and the vector B. This is the vector B. Know what? And we simple say that keep focus here, please. Keep the tail of second vector on the head of first vector. This is the first vector, this is the head of the first vector, and this is the tail of the second vector. So simple the line will be keep the tail of second vector on the head of first vector, and then join the tail of first vector with the head of second vector, and this new vector will give the resultant vector of these two vectors, vector A and vector B. That is the resultant vectors of these two vectors, and this is the vector law of addition. Okay, and detail you will study in the basic physics. So this is a vector form. Now the questions arise that why we need to describe the direction of the force. You know what, forces are a vector, are all the vectors, and in the vector, you know, it's very important. It's very important. We have to also indicate with direction. We will have to show the direction. Let's suppose we have any vector like what we say. This is the vector. Okay, this is vector F. So we have the both the things. We have magnitude and as well as direction. We have the both the things. Look at this. F is equal to K Q1 Q2 by R square, and here not mention any direction in the form of this type of forces. It's showing only magnitude, and that is not a complete form of vector. So we will have to add an additional vector to show the direction of this vector. Then after this vector will actually a vector like vector F. This arrow will indicate the head of this F, and we have for direction, this is the unit vector R1 2. That means what we say, that the distance from 1 to 2, and see the magic, you will get the two types of forces. That means we should not say that these two types of forces. Actually this is the Coulombic forces, but these are Newton's third law of motion, action reaction pair of forces. Now F21 force on 2 by 1, F12 force on 1 by 2, right? And these two vectors, these two forces will in action reaction pair of forces, equal in magnitude, opposite in direction. Simple. And we say that F1 F2 F21 will get a sum of 0. Simple. Next we say about force representation. Many times it's create a lot of confusion that how to decide the direction of any vector, and many times we see negative and positive with vectors. So basically in vectors, positive and negatives are for direction, only for direction, and nothing work. This is only for direction. Let's suppose we have the point this one, and this is the upward direction, this is the downward direction. So we will decide that in upward direction we assume this is the positive charge, this, sorry, positive, not we say positive charge, this is the positive direction and this is the negative direction. So then when we say -5 Newton, I'm not saying upward and downward, but when we talk -5 Newton, you will understand, okay, sir is talking about -5 Newton. That means minus will represent the sign of the downward direction, that is the sign of negative charge. Okay, when we say the 10 Newton, without saying anything, you will capable to understand this is the upward direction. So this is the magic of the physics with the vector when we talk about, and simply any vector is represented to magnitude as well as direction. So very simple, I already told about it. Vector addition, I already tell about it, what is the vector addition, and this is the examples I will describe here. The next slide, and Coulomb's law, I already discussed about his Coulomb's law and vector form representation. And then this is the force component. It's very important. You also learn in laws of motion in chapter 3, where we find the component of vectors, that we say that this is a vector F, and we describe, we break the component of this vector. Doesn't matter what is the vector. Let's suppose here is the force, and force is a type of vector. So we will break the force in two directions, like we have the 3-dimension form. This is the x-axis, this is the y-axis, this is the x-axis, and you know what, a particular direction is mentioned in the physics. For x-axis, it's denoted by I cap, and I cap is actually a unit vector that is represented. When we talk about I cap, you will understand this will work on the x-axis, and for y-axis, it is represented by unit vector j cap, and for z-axis it is represented a unit vector k cap. Very simple way. K cap means z-axis, I cap means x-axis, j cap means y-axis. So that's the same way we break down this force as let's suppose this is the angle theta. Okay, this is the angle theta, and now we say that this is the component along x-axis f cos theta I cap and f sin theta j cap. So very secret way I tell you, without any confusing, you will get the exact component of any force, that the line which will make the angle theta, that will always cos theta. Always remember this line, this statement, always remember. The line which will make the angle theta always the component of cos theta, and the remaining line will be sin theta. The simple, we have the two lines, one with theta will cos theta and other will be sin theta, and this is the form f is vector f is equal to f cos theta I cap plus f sin theta j cap. And this is the way that we say that any vector have the both things. We say that this is a vector f. What do you mean by vector f? What do you mean by vector? Vector means that we have the magnitude and direction as well as direction. We only focus the magnitude. No, only with magnitude, never ever it will be called a vector. When we describe with direction, that it will complete to make a vector form. Like we have to show only magnitude, then we will have to keep mode with this vector f, and simply it's also represented only f, that is the only magnitude. So this is the form of the vector, with magnitude, without magnitude, with direction, without direction. It's your choice. And always remember angle between two vectors. So the angle between two vectors, the concept is very simple, like your finger. Look about it, this finger is like a vector and this finger also like a vector, and this is the head of this vector, this is the tail of the vector. Again say that this is the head of the vector, this is the tail of the vector. So this is the angle between the two vectors. Look about it very carefully. This vector, the tail is here, and for this vector, tail is here. The angle is between tails of the two vectors. So always the angle between two vectors will make between tail of these two vectors. Never ever say that one tail and one head, that will not make any angle, and that will not call the angle of these two vectors, of those two vectors. It's your choice, whatever be. And here we say that force triangle example. let's suppose an example that we have a triangle shape and we have three charges, like the vertices of the triangle A, B, C. The charge plus Q is situated on the A, and again plus Q on B, plus Q on C. The similar charges, the same value of the charges, we keep all the vertices of the triangle, right? And we're not describing about any type of triangle. We are not describing the distance between. In the specify, it will specify in particular questions that will ask to you that this is the distance between, this is the side of the triangle, this is the amount of charges, then find the value of a particular resultant charge on that point or dot point. So now in this case we will target and we will focus on point A. Look about, we have the 3-point charges. This one, this is the point A, this is the point B, and this is the point C, and we want to find the total charge on point A due to point B and point C. What am I saying? Due to point B and point C, let's suppose this is an isolated system and we will describe on any point, on a specify point. I'm talking about a specify point. Let's suppose the question is asking to ask you that find the total charge on this point, then we will work on particular point, not this and this. Due to means what? It's only a type of effect. And let's suppose we say that this is the plus Q and this is the plus Q, also this is the plus Q. So when we discuss the 2-point charges A and C, then we will ignore that time B. We will hide the B and only focus A and C. Look about the charges. Both the charges are positive. Both the charges are like charges. That means the force will be repulsive forces. You already studied the starting of the class. I already told you that in the like charges, the nature of the force will be repulsive force, and that's why we will make the line for the forces. This will the repulsive force. This will repel this the upward direction, in the direction of this line, not any direction. This is a line, the direction. And again, when we will find between the point A and point B, we will hide the point C, only the focus on point A and point B. And again we say that these two charges are the same charges, that means the positive charges, and the nature of forces will be the repulsive force, and again it will work along the line between point A and point B, and this is the line of the force on A. I again repeat, we will have to very carefully read all the lines, what is asking in the questions, what we have to find actually. So this is the point A where the two forces are acting such like a different directions, and now at every, this is like FB and this is the FC, and we will break into the components of the force, like this one, this force will component this one, this and this, and this also, this force will be break in the component this and this. Let's suppose this is the FV, this is the FC, that means let's suppose this is the angle theta here, this is the angle theta here, so FB cos theta, and this is the FB sin theta. Again we say that this is the FC cos theta and this is the FC sin theta. See the magic, that all the charges are equal and on all the points. That's why we say that FC cos theta will equal to FB sin theta, and these two will cancel to each other, and the net resultant force of the point A is very simple. This one is the net resultant force, and this is what FC sin theta and FB sin theta. And we say that if FC and FB be F, that means 2F sin theta. It's a very simple way. It's very deep knowledge. I'm describing in very detailing. Not a single concept I'm missing here. Only focus here. And after a practice of many questions, you will get confidence that yes, you can solve this type of questions. Only showing the video, only thinking that it's okay, I understand. It's no okay, I know. So I know the funda of I know will not work on your exam. Remember it. What you write, how do you practice, how many times you practice, and the most important, how time you take to solve any particular questions that will decide your marks in your exam. Many students are asking that, sir, I completed my all the syllabus. Can I get 90% in my exam? Is it possible? How it's possible? How it's possible? When you solve any question 10 minutes, 15 minutes, and you have only 3 hours, only you will get, only you are capable to solve 50% of your question paper. And what will happen with other 50%? What will happen? So practice makes a man perfect, always remember, right? So don't worry, I'm not making you demotivate, only I am just alert you. And this is the questions, this type of this, that's a glass rod when rubbed with silk cloth acquires a charge Q is equal to plus 3.2 into 10 to the power 17 coulomb. Is silk cloth are also charge? Yes, ये दोनों ही both are charge. And what is the nature and magnitude of the charge on silk cloth? Both are equal. So this all we will stop here, because my next class is the organic chemistry on YouTube. We will meet again the next class on demands of students. So if you want to continue this type of series, that series where we explain all the thing in English and you enjoy, then I will continue the second part. Otherwise I'm so busy person, all the live classes I attend from morning to night, and it's a very busy schedule. It's very schedule. You know what, today is biology practical, and today I was time to make this type of video, so I decided to make make this type of videos to understand properly in English medium. So what's your opinion, or what's your feedback? It's very important for me, that according to that I will make that next part and other thing, what can we do something in a way. Okay, so thank you so much all of you to making this session very interesting, powerful and excitement, and we will meet again the next part. So bye bye from here, and keep learning. Keep learning means keep learning, hard working with smart way. Thank you so much again. Jai Hind, Jai Bharat.